Hello everyone. So in this video we will be discussing this LeetCode problem which was asked in the bi-weekly contest 175. So the problem is a minimum k to reduce array within limit, and the problem is like we are given a positive integer array nums, and for a positive integer k, uh, okay, for a positive integer k, so we have some function non-positive nums of k as the minimum number of operation needed to make every element of nums non-positive. So what does that mean? So for example, we have this array and we choose, for example, k equals to 4. To make 3 a negative number, we can subtract 4 from it and we will get -1. To make 7 uh, a negative number, we need to subtract 4 twice, so we will get a negative number, and same for 5, we need to subtract 4 twice. So that is what this function is doing. It is like finding that k, and like that in one operation, like what I stated, in one operation we can choose the index I and reduce nums of I by k, and what we have to do is we have to return the minimum integer denoting the value of k and where this condition suffice. Okay, so this is what they have asked. So let us just move to the board and we will discuss it and how we can do it. Yeah, so let us consider this is our array, and what we need to find is we need to find a certain k. We need to find that this function we have given, so I'll just write it in numpy, and we have our nums and k. It should be less than equal to k square, right? And what this function is giving, it is giving, so for example it is giving a value. So if we take 4, so it will take 1. We have to perform one operation on this 3 to make it negative. For 7 we have to perform the operation twice, that is 7 minus 4 minus 4 to make it negative. For 5 we have to do the operation 2 times again. So if we add them, 1 plus 2, 3 plus 2, 5, so we have 5, and 5 is less than equal to 16, which can be our one of the answer, but we need the minimum. So if you have like done problems like aggregate cows and all those, so you might it might strike you off very instantly that we need to apply binary search here. Also the constraints are 10 to power 5, so we cannot go above like we cannot go n square, so we have to go for the binary search, and I'll just discuss the time complexity beforehand here. So the binary search takes log of base 2 n, so here n will be 10 to the power 5, 10 to the power 5 instead of n, which comes out to be somewhere around 17. And there will be another n in the solution that we will look shortly, so it will be 17 times n, even though 17 is quite big as a constant, but it is still we can say n log n. Yeah, so let us move ahead to the solution. So this is our array 375. For binary search, what do we need? We need a low, we need a high. So our constraints are from 1 to 10 to power 5, and our low will be 1 and our high will be 10 to power 5. Okay, why we are taking high 10 to power 5 instead of the maximum value of this array? Yeah, one can say like if we have this array and we have a maximum value of 7 here, so we know if we do the operation with the maximum value of this array, we will be able to do like perform only single operation on each element, and we will get a negative value. So for example, I have 7, right? With one operation I can make it negative. If I have 7, here it will take 2, here it will take 1, and it can be done. So we can do something like high is equal to the maximum element plus 1, and with that we can do everything in just n operations, and we can find out, but that is where this will not work. I'll show you one sample solution. Okay, just keep this test case in mind, 1 1 1 or 1 1. So we will discuss this test case later on. So now let us move to our solution. So our solution is 1 10 to the power 5 medium. Somewhere we will find the mid, but for this example I'll be taking it as 7 only. For this example I will be taking it as 7, but our high will be this value, not 7. For simplicity I'm taking it 7. So this is our low, this is our high. Our mid will be 4, right? Our mid will be 4, and now we need to calculate this number of operations or whatever we say. So how can we go it? We can say, okay, 4 is our one of the candidate. 4 is our one of the candidate, so we can go into that function and there we will perform some operation. What operation we will perform? So let us have a look. So I have 3, right, and my this 4 is my candidate. So I know 3, if I do 3 mod 4, I will get something as 3, right? If I do 7 7 mod 4, I will get something as 3 again, and same for 5, I will get 1 as mod. So what we can conclude from this one, if I have some value num of I and I have this candidate k, if I have 3 divided by 3, it will give me 1. If I have 4 divided by 3, it will give me 2. Till the next multiple, like 6, I will get 2 only. So from here we can conclude that if it is a direct multiple, then we will get the whatever value we will get after dividing. But if there is some remainder left, then we can add 1 to it. So our another function will look like something like this. Okay, I'll just name it func. We'll have nums and we'll have our candidate k, right? And I can just take count equals to 0 and I can loop on my nums, right? I'll just write auto here, and here I can get a count plus equals to nums of I divided by k. And now if I'll check if nums of I mod k equals to 0, not equals to 0. If it is equals to 0, then I don't have to do anything. This will be my count, but if there is some remainder value, I can just do a count plus plus, and in the end I can return count. So this is this function. Now let us just move to this one. So we had 1 4 and 7. This was high, this was low, this was mid, right? So we got for 4, what do we got? For 4, 3 7 5. We had 3 7 5, and with k equals to 4, this can be done in 1 operation, this can be done in 2 operation, and this can be done in 2 operations. It is total 5, so 5 is less than equals to 16, which is a 4 square. So we see our condition is true, it is meeting. Then 4 is one of our candidate and it can be one of our answer. Since it can be one of our answer, but the question asks for the minimum, it asks for the minimum one. So here we can do one thing. Since it asks for the minimum, our high will go mid minus 1. So next time we have something like 1, which is my low, 3, which is my high, right? Yeah, and this time mid will be 2. We will do the same operation for 3 7 5. It will take 2 operations, it will take 4 operations, it will take 3 operations. This will be 7 and 2 9. 9 is less than equal to 4, which is 2 square. Condition is false. Since condition is false, we will move our low up. So now we have something like 3, which is our low. We have something like 3, which is our low. We have something like 3, which is our high. And this time our mid will also be 3. Now we will do the same for 3 3 7 5. Okay, 1 operation, 2 operation, 2 operation. Okay, we get 5. 1 operation, this will be 3 operation, we get 6, right? Now 6 is less than equal to 9, which is true. We will update our answer to 3, which is lesser than 4. And after that we will move our high to mid minus 1, which will be 2, and we can come out of the while loop, because our while loop will run from low less than equal to high, right? So that is the basic idea how we will be doing this binary search here. I'll just move directly to the code. So as for the code, we are getting the size, we are setting the low and high and answering some very high value. Then we are entering into our loop where we are doing the binary search. We are getting the mid, and this function is calculating the thing that we discussed, and it is returning a count. If the condition is true, then we are updating our answer and we are moving high to mid minus 1. If it is not, then we are updating the low, and in the end we are just returning our answer. So I hope you have got how this was solved. Also, the next question was a DP thing. Yeah, so thank you for watching the video, and I hope you really enjoyed it, and do subscribe the video, do subscribe to the channel.